So let us start now. This is new chapter, that's thermal expansion, right? So we are going to discuss the expansion of substances due to rise in temperature. So what we are going to discuss? We are going to discuss expansion of substances due to rise in temperature. Due to rise in temperature. All right. So we will discuss linear expansion. That is when the expansion is along the length. So we will discuss next is superficial expansion or surfacial expansion. So this is when there is expansion in the area. And we'll also discuss the volumetric expansion. When there is expansion in the volume. This is basically one dimensional, this is two dimensional, and this one is three dimensional expansion. Okay. All right. Now, let us try to understand a term here that is called as thermal agitation. Now, what is thermal agitation, or what happens when we provide any substance with heat? When we give heat, what happens? So, what is thermal agitation? Right now, whenever if you consider substance, right now, substance there are many atoms. Right, there are so many atoms present in the substance. So these atoms, they undergo, they are in the random motion. They are vibrating like this. They are vibrating. They are vibrating like this, in different. But they do not. These atoms are fixed in their position. They are right. They have a fixed position here, but they are vibrating randomly. They are vibrating. So when we provide heat, what happens is that their vibration increases. Thermal agitation, or when we provide heat, their random motion or oscillation of the vibration that increases. Right. So thermal energy causes what? So thermal energy basically causes thermal agitation. Thermal energy causes the atoms to oscillate randomly. Randomly. Okay, if temperature is 0 Kelvin, then it is not going to oscillate. There will be no oscillation. As temperature is increased, thermal agitation increases or oscillatory motion increases. Atoms they start to oscillate randomly. Okay, so one thing we should understand that this thermal energy or agitation energy, we can say, is directly proportional to temperature. That we'll discuss in kinetic theory of gases also. So the thermal energy, or let us say the agitation energy, this is directly proportional to what? Temperature. So as we increase the temperature, thermal energy increases or the agitation energy increases. Right? These atoms they start to oscillate more randomly. Right? Their energy increases. And since their energy increases, they start oscillating more randomly. There is an expansion. There is an expansion in the substance. This is called as thermal expansion. So one thing we should understand, when we provide heat to a substance, right, two things can happen. One is there is a rise in temperature, because as you provide heat to a substance, there is a rise in temperature. And another is there is a change in phase. Change in phase means what? From solid to liquid, liquid to gas, all this. And there is thermal expansion. Since there is thermal expansion, there is change in phase. So change in phase and thermal expansion are related. All right. So you please note down till this point.
सर आपका माइक बंद आ रहा है.
So what is temperature? Temperature is the degree of hotness or coldness of the body, right? So with the help of the temperature, right, we can understand which body is more hot or cold, right? And we know that we can measure temperature with the help of thermometers. There are different types of thermometers. So first we are trying to understand what is temperature. Temperature is a degree of hotness or coldness. Just like you have two substances, A and B. So A may be more hot as compared to B, or B may be more cold as compared to A. So how do we know that which is more hot or which is more cold? That is only by measuring their temperature. Correct? Okay. So what is temperature? We can also say that it is a measurement of energy. Of what? Of random oscillations of particles. Of random oscillations of particles of a body. Okay. So temperature is the measurement of the energy of random oscillations of the particles of the body. All right. Okay. Now, how do we measure temperature? So we are going to talk about measurement of the temperature. So we know that it is measured by thermometer. That's true. But thermometer will use some physical property of substance, right? So for a system, or for bodies, how do we measure temperature? So we measure temperature by measuring some physical properties. By measuring some physical properties of the substance. Basically, I'm talking about system or bodies, which varies with temperature. Which varies with temperature. All right. So there are different physical properties, just like length, area. So we can have length, area, or volume, which may vary with temperature, and then we can calibrate as per the variation. Let us say if the variation of length is directly proportional to change in length temperature. Temperature. So we'll get a linear graph, and according to this, we can make a thermometer. All right. Or let us say, if we are using a gas, then the pressure of the gas. So there may be a gas whose pressure is varying directly with the temperature. So we may use that gas to make a thermometer. Or we may have the resistance of a wire. There are some wires in which the resistance of the wire will vary directly, will be directly proportional to the temperature. So we can measure the change in temperature by measuring the change in the resistance of the wire. Or similarly, there we may use the refractive index of any substance. So there are so many possibilities, right? So please note down till this point. Okay, so what is thermometry? Let us understand that point. What is thermometry? So thermometry क्या है? It is the science of measurement of temperature. This is thermometry. And devices used for measuring temperature are called as thermometer. So you have seen the normal thermometer, right? That is Hg in the glass thermometer. So we are talking about the glass thermometer. तो उसमें क्या होता है? There is expansion of Hg, right? तो नॉर्मल आपने थर्मोमीटर देखा है, तो उस थर्मोमीटर में यहाँ पे क्या होता है? Hg होता है। और जैसे ही आप इसको हीट प्रोवाइड करते हो तो ये Hg क्या होता है? ये कैपिलरी में एक्सपैंड होता है, एक्सपैंड एक्सपैंड एक्सपैंड, और ये बताते हैं कि टेम्परेचर कितना है, 97.3 डिग्री फ़ारेनहाइट, जो भी है टेम्परेचर बताता है। तो ये है अपना ग्लास थर्मोमीटर। तो यहाँ पे क्या चीज यूज हुआ है? यहाँ पे यूज हुआ है एक्सपेंशन ऑफ Hg, लीनियर एक्सपेंशन, ये प्रॉपर्टी यूज की है, राइट? एक्सपेंशन ऑफ Hg का यहाँ पे क्या हुआ है? यूज हुआ है। फिर वैसे ही दूसरा एग्जांपल ले सकते हैं हम लोग, प्रेशर थर्मोमीटर। जो प्रेशर थर्मोमीटर है उसमें क्या है? उसमें एक बैरोमीटर टाइप यहाँ पे ये एक गैस चैम्बर है, ठीक है, या तो यहाँ पे आप कनेक्ट कर रखे हो उसको एक यूट्यूब बैरोमीटर टाइप है ये, इस तरह से। और यहाँ पे एक लिक्विड है, ठीक है, और हम लोग जो है बेसिकली जो गैस है, गैस को हीट देंगे, वी आर हीटिंग द गैस, राइट? और मतलब हीट क्यों कर रहे हैं? जबरदस्ती हीट नहीं कर रहे हैं, हमें टेम्परेचर मेजर करना है। तो हमें जिस सोर्स का टेम्परेचर मेजर करना है वहां पे हमने इसको रख दिया है, सोर्स में रख दिया है। इस सोर्स का हमें टेम्परेचर मेजर करना है, तो वहां पे ये जो बल्ब आपको दिख रहा है जिसके अंदर गैस है, वो हमने रख दिया है। तो जब जैसे ही उसको हीट मिलेगा तो ये गैस एक्सपैंड होगा, ये गैस एक्सपैंड होगा तो ये लिक्विड जो है इधर से इधर ऊपर मूव करेगा, और ये आपको बताएगा यहाँ पे कि टेम्परेचर कितना है, इस तरह से। तो ये है आपका प्रेशर, राइट? जब ये एक्सपैंड करेगा तो लिक्विड इधर से इधर मूव करेगा और ये ऊपर जाएगा और आपको ये बताएगा कि रीडिंग क्या है। तो यहाँ पे भी क्या यूज हुआ है? यहाँ पे यूज हुआ है एक्सपेंशन ऑफ द गैस, ओके। तो लीनियर एक्सपेंशन ऑफ द गैस हो रहा होगा इस पर्टिकुलर गैस के लिए, इसलिए हमने ये गैस यूज किया है, ऑलराइट। चलो लेट अस नाउ अंडरस्टैंड द डिफरेंट टेम्परेचर स्केल्स। तो आप लोगों ने ऑलरेडी सुना हुआ है, there is degree Celsius, degree Fahrenheit, and Kelvin scale, right? Okay. So how do we define, the temperature scales? That is the very basic question. For that, we have to use the steam point and the ice point, okay, to define a temperature scale. So the steam point and ice point, basically talking about the water, because water का ही steam point होता है, ice point होता है, right? So to define a temperature scale, 2 points are specified. Okay, so we have two fixed points are specified. So which are the two fixed points? So one is the steam point, that is 100 degrees Celsius. Another is the ice point, that is 0 degree Celsius. So this is on the Celsius scale. But this two will remain the same, only the scale will change. So basically, we have to take the steam point and ice point as the two fixed points. Only thing is that in Fahrenheit scale, you may call it 32 degree Fahrenheit. You may call this as 212 degree Fahrenheit, like that. That's all. In Kelvin scale, you will call this as 273.15 Kelvin, and this you will call it as, right? You have already heard of this, right? All of you? Yes?
Yes.
Okay.
Yes,
So,
sir.
very good. So let us talk about this. So there's one thing common for all the scales. So for all the temperature scales, we will use a common formula, that is temperature reading minus ice point, temperature reading minus ice point divided by steam point minus the ice point. Steam point minus the ice point. So we are going to use this formula for all the temperature scales, because this will be constant for all the scales, right? So we are going to use this formula for all the scales. So what is this called? This is called as thermometric scale identity. This is called as thermometric scale identity. All right. Okay. So please note down till this point. Okay. So now we will see 5 different types of scales which are used to measure temperature. Okay, let us start. So there are 5. The first one is the Celsius scale. Okay, so I will tell you these things: the symbol, ice point, and the steam point. Okay, the symbol is degree Celsius, and it's 0 degree Celsius, 100 degree Celsius. The second one is the Kelvin scale. The symbol is K, and this is 273.14 Kelvin, and this is 373.14 Kelvin. This is also known as the absolute scale. The third one is Fahrenheit scale. The symbol is degree Fahrenheit, and the ice point is 32 degree Fahrenheit. The steam point for this is 212 degree. Right? Next one is the Reaumur scale. Okay, we don't use it now much, but it's there. The Reaumur scale is degree R, and for this, the ice point is 0 degree R, and this is 80 degree R. All right? And the last one is, that is called as the Rankine scale, which also we don't use now so much, right? Its unit is RA. For this, the ice point is 460 Rankine, and the steam point is 672. It is 672. All right. 672 Fahrenheit. Right. So please note down this, all of you. Now, suppose that if you want to convert a reading of Fahrenheit scale to Celsius scale, so let us just take a simple example here. So what will be our formula? Convert a reading of Fahrenheit scale to Celsius scale. Okay. Okay. So now we have seen this, TSI, thermometric. What is TSI?
Thermometric scale identity.
Yes, very good. So according to that, this is the temperature which we are measuring in Celsius. So temperature in degrees Celsius. So minus the ice point divided by steam point minus ice point is equal to degree Fahrenheit minus ice point divided by steam point minus ice point. So this is, we'll use this to convert. So we'll get C by 100 is equal to F minus 32 by 180. Okay. So what will be C from here? So from here you will get C is equal to 100 by 180 into F minus 32. So this is 5 and this is 9. So C is equal to 5 by 9 F minus 32. So this is a relation between degrees Celsius and Fahrenheit. We can convert Celsius into Fahrenheit. Alright. So please note down this, all of you. Okay, that's it for today's lecture. Tomorrow we'll discuss thermal expansion, types of thermal expansion in the next lecture. Right? So if you can write this and then let us stop. Right?